you welcome to this EDU-ARCTIC online lesson about where we will talk about the North Pole or in plural the North Poles. My name is Lis Mortensen. I'm educated as a physical geographer, and I work at the Geological Survey in the Faroe Islands. Let me just continue. And normally we say that the North Pole is on the very top of the Earth, somewhere up here. And of course, telling this story, there's more to it than just this location. What I just pointed to is, of course, what we would call the geographic North Pole. The Earth seems to spin on an axis. We know it takes one day for the Earth to spin one time around its own axis. And this axis, as shown on the picture, is tilted a little bit in relation to the Sun. The axis seems to point to a special star in the heavens, the North Star, called Polaris. And if you know this star, you can actually find the North. You can use it for navigation, and that's what it's been used for many thousand years. So the North Star, Polaris, you need to find the Big Dipper. Let me show you on the line here where the Big Dipper is. And then you take one wall of the Big Dipper and it points directly towards Polaris, the North Star. And if we then look at a photograph taken for a long time, then we can see how the stars seem to circle around that one point, the North Star, the Polaris. So that's how Egyptian, Arabs, Greek stargazers noted that they discovered this 3,000 years ago, that the heavens seem to circle around that one point, the North Star, the Polaris. The geographic North Pole, that is where the longitudinal lines of the Earth, when we put a coordinate system around the Earth up to that point, where the axis of the Earth is, that's the geographic North Pole. The geographic North Pole is, you might call, there's no land there, it's in the middle of the ocean. It's very deep. It's 4,600 meters deep where the geographic North Pole is. So it's kind of a mathematical point, you could say, but it's extremely important for navigation. We've had a tool for navigation for more than 2,000 years. That is the tool of the magnetic needle. The magnetic needle has been used to find north. We use the compass. The Chinese invented this method of finding the north, and it's clear. We can see when we use a compass or anything that's magnetic, we can see how it points towards a place. But we find out that it doesn't really point towards the geographic north. It points to another place, another North Pole, actually. And the reason behind this is that the Earth is a magnet. There's an inner core, solid inner core in our planet, and around that inner core is a liquid outer core that has a lot of metals in it. And as this molten material evolves around the inner core, that creates a magnetic field which turns the Earth into kind of a magnet. A bit like maybe we know this dipolar magnets with a south pole and a north pole. In a very complex way, we can compare this with Earth's magnetic field. So we have the north magnetic pole, we have the south magnetic pole, and we have these fields around the Earth compared to the geographic North Pole that we just talked about. It is about it's a little bit more than 11 degrees tilted away from the geographic North Pole. Maybe actually it's much less now. That's an exciting story. That's probably not the right number at the moment. We'll come to that. So the Earth has a magnetic field, and that can be used in navigation when we have used the compass, when we use a magnetic needle. And what's interesting is that the magnetic pole, it moves, or both of them, both the North Pole and the South Pole, they move. And this fun image that I hope you can see shows us how it has moved from the 1960s to about to actually this year, 2019. This is a very important knowledge, a very important map to know exactly where the magnetic North Pole is. It's important in a lot of our navigation tools, even for our smartphones that many of us have with us. This movement of the magnetic pole, the magnetic North Pole, you can see on maps. It will be called the magnetic declination. So every year they follow where is the magnetic North Pole now, where does the magnetic needle dip into the Earth. And actually this year it had moved so much recently that in a bit early they had to announce a new magnetic North Pole. It's this picture on one side shows how it has moved since 1590 up to the 1600s and 1700s and 1900s, and then the past 10 years or so, 20 years, it's been speeding northwards. So on the 5th of February this year in 2019, there were breaking news around the world that now a new model had been published a new model to show where the North Magnetic Pole is, so that all these systems that we use and maps can be more correct, which is so important for our navigation. So the magnetic North Pole is really on a run at the moment. And as you can see in the picture, it is quite close to the North Pole, the geographic North Pole at the moment. The movement, we looked at the movement of the magnetic North Pole from the 1500s and up to early this month, actually, in February 2019. This has gone on throughout all history of Earth for billions of years. Earth is about 4.6 billion years old, and this has been an active process through that whole time. And this means that the old magnetic North Poles, they can be frozen in the rock. And you wonder, how can that happen? What do you mean by that? Well, if we take a piece of rock, like that one I have on the picture, the basalt. The basalt has a lot of metals, of magnetite, of iron, of minerals that can be magnetized. And when they are molten, when they are lava and they are flowing out on a surface, these molten minerals, they flow along, and as they are free to move because they are almost liquid, the minerals that can be they are sensitive to the magnetic field of the Earth at that time when they're molten. Then they can find their way and point towards the magnetic north. And then the rock cools, of course, and then they can't move anymore. So that way, the old magnetic North Poles become frozen in the rock. And that's a very important information that these rocks can give us, as we can see from the ocean floor. Here's a map of the ocean floors, where you can see some lines that go through the Atlantic Ocean and go through the Pacific Ocean. And you can see that there are colors going from red to yellows to blue. And these lines show, every line show a change in the magnetic field. And because it's frozen in the rock, that gives us an estimate of the age of the rock. And all of a sudden, this information about the magnetic poles gives us a very interesting and exciting information about about the age of the ocean floors and how our ocean floors evolved. So there's a lot of information in magnetic poles. There's one more North Pole. We talked about the geographic North Pole, which is where all the longitudinal lines meet in the center of that figure. We talked about the magnetic North Pole, which has just been stated on the 5th of February 2019, where it is, because it's changing so much at the moment. But then we have a third North Pole. It's called the geomagnetic North Pole. And this geomagnetic North Pole is kind of a mathematical figure. It shows the average, maybe that's not the right word, the average field for the North Pole, looking at the whole Earth, and it is stationed at the moment in the Arctic of Canada, northern Canada, Ellesmere Island in that area. And why is geomagnetic North Pole different from magnetic North Pole? Well, we can see they're quite a bit apart, at the moment at least. And what is so intriguing with the North geomagnetic pole is that the North geomagnetic pole is the center of the Earth's magnetic field. So when the figure we had before about the whole Earth's magnetic field, then the North geomagnetic pole is the center of that field. And there's an oval around that North geomagnetic pole that is called the auroral oval. So the geomagnetic pole gives us is the center for the northern lights, or the auroras that we see in the northern hemisphere. It's tilted. It's a bit towards a little bit away from the geographic North Pole. It's not the same place as the geographic North Pole as we saw, which means that in some areas, like in northern Norway, it's far up in the northern Norway before we see the auroral oval. And at the same time, it reaches actually quite south into Canada. And you can see northern lights actually quite far south when you come to North America. So it's tilted that way. And these are the places where people can enjoy the northern lights. The magnetic field around Earth has a very, very important function. The function of the magnetic field is that it shields the atmosphere around the Earth against storms from the sun, solar storms. So when these storms come from the sun that embrace the whole Earth, then they are bended around the magnetic field, and the Earth's magnetic field protects the atmosphere of the Earth. So we're quite lucky, actually, to have the magnetic field. Well, we talked about the three North Poles: the geographic North Pole, the North Magnetic Pole, and the North Geomagnetic Pole. I found one extra North Pole. There's actually a city in Alaska that's called the North Pole. And judging from this picture, it looks like they are quite happy about declaring this a place where Santa Claus and Christmas as its center. So let's conclude this morning that we have the three North Poles and an extra one. We had the geographic North Pole, which is the place where all the longitudinal lines meet on top of the Earth, on this axis that's a little bit tilted compared to the sun. We have the magnetic North Pole, where we have the magnetic field around the Earth, and the place where this field dips into the earth. If we had a needle, that needle would point downwards to the earth. That is the magnetic North Pole. And then we have the third, that is called the geomagnetic North Pole. And the geomagnetic North Pole is the center, if you like, a mathematical center for the whole Earth magnetic field. And then we have our nice little city, North Pole city in Alaska. So with these little stories about our 3 North Poles and the extra, I will say thank you. If you have any questions, please feel free to ask anything.